We're here again for Mathematics Meal. Welcome to Mathematics Meal. I believe you are doing fine. Yes, I know you are doing fine. Today on Mathematics Meal, we are going to look at our sequence, the second part of sequence. That's part 2 of sequence. And in this part 2, we'll be looking at n term of what? Of a sequence. Subscribe to our YouTube channel and make sure you follow us on Facebook. Our YouTube channel is Mathematics Meal 1 and our Facebook page is Mathematics and Science Meal. You can also follow my Facebook profile at Engineer Ike Okechukwu. Alright, now let's begin. Now last time we described sequence and we also explained what we mean by the term of a sequence. We also talked about the number of terms in a sequence. Now we want to talk about n term of a sequence, and we are going to define the n term expression, and then from there we explain further what we mean by the n term of a sequence. Now the n term expression of a sequence, so let's say the n term expression of a sequence is an expression used in finding terms of a sequence. So the n term expression is an expression that is used in finding the terms of a sequence. Let's go further before we start explaining. It connects or it establishes a relationship between the terms and the number of terms. So we usually denote or represent the n term using Tn or Un. Okay, so we say the n term expression is an expression that is used in finding terms of what? Of a given sequence. And we say it connects or it establishes a relationship between terms and the number of what? Terms. And we said we are going to use this or this to represent it. There are some cases that other letters can be used. We can still use this to represent it, and so on. So here we say we use this or this. So when you see something like this, they can still use it to represent n term of a sequence. Now in our last video, I think I talked about n, the number of terms. So I can add here where n is the number of what? Of terms. Where n is the number of terms. Now let's look at what n term is all about from a sequence. Let's say I have a given sequence. I have 3, I have 7, I have 11, I have 15, I have 19, I have 23, I have 27, and so on. Now you know that these terms can continue until you get to a particular term n that I don't know. You see that? I have the first term, second term, third term, fourth term, fifth term, sixth term, seventh term. It continues that way until a particular term that we don't know. You know, if you are asked to find the 8th term now, you will just add 4. You get the 8th term. So here we added 3, we added 4 to get 7, add 4 to get this, 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 add 4 to get this. If you add 4, we can easily get the what? The 8th term. If you add a 4 again, but if I ask you to find the 100th term, what are you going to do? So you continue to do that, add 4. When the board is filled up, you continue. You just be, maybe you use the whole field, you'll be adding 4 to get the 110. That would be very clumsy, very, very clumsy. And that's why we can now have an expression that can be used to find any of the 10. You see that? If I ask you to find the 20th term now, you start again. I added 4, I added 4, I added 4, I added 4. People may now think that you are mad when you be doing your hand. I add 4 to this, I add 4 to this, I add 31, add 4, 35, add 4, 39. Is that what you are going to do? that would be semi-madness. So we can't continue to do that. And that is why there can be a mathematical formula or a mathematical expression that we can establish, that anytime we need any particular term, we just need to do something with that formula and we get that term. So that mathematical expression or mathematical formula that will always give us any term that we want to determine in a given sequence, that mathematical expression is what we call the n-term word expression. So the n-term means any term. So if I now say that Tn is n-term, if I say T20, that means I'm talking about the 20th term. So you see that n-term means any term in the sequence. So if I now say T1, that's the first term, and the first term here is 3. If I say T5, the 5th term, because we have said that n not represent the number of terms. The 5th term now I will be going to what? 19 for this particular sequence. So that mathematical expression that we are going to use to determine any term at any point in time is what we call the word, the n-term. That's what we are trying to display. Now, we are still going to look at types of sequence. We are still going to look at types of sequence because we have 2 main types of sequence. But now we want to actually see n-term of what? Of an arbitrary sequence. So we have mentioned one of the uses of n-term. We say the n-term expression can be used in finding the word, the term in a sequence. Yes. And this n-term expression connects terms and the word and the number of terms. So in that formula, 2 things are connected: the term and the word, number of terms. They are the things that are connected in the word, in any n-term expression. So when the n-term of a given sequence is known, then the terms of that sequence can be what? Can be calculated. So when the n-term of a given sequence is known, the terms of the sequence can be calculated easily. Okay, so finding terms using n-term, that's the first thing we are going to do. Finding terms using n-term expressions. To find a term using a given n-term expression, we do the following. 1. Take note of the n-term expression. Substitute the given value of n in the expression and simplify to find the term. So we said earlier on that the major use of the n-term expression is to find terms in a sequence. So once the n-term expression of a given sequence is known, then we can actually find the terms of that word of that sequence. So the question is, how do we use the n-term expression in finding the terms of a sequence? We say to find a term using a given n-term expression, we do the following. Take note of the word n-term expression, then substitute the given value of n. You remember we have defined n as number of terms in the expression and simplify to find the word, the term. Okay, quickly, we're going to take examples. Let's take examples on that. So we take example 1. Let's take example 1. The n-term of a given sequence is given by Tn equals 2n minus 3. Find the A, fifth term, B, the 10th term, and C, the 21st term, T21. Alright, so let's go together. The n-term of a given sequence is given by n-term equals 2n minus 3. And we are asked to find the word, the 5th term, the 10th term, and the word, and the 21st term. So this 21st term, remember T stands for term here, 5th term, 10th term, 21st term. Now in our definition of n-term, another explanation that we gave, we say something. We say the n-term connects the word, the terms, and the word, number of terms. So if you look at this particular expression, now we have this. Sorry, minus 3. Do you notice that this is a term and this is number of terms? So the terms are connected to the number of terms by the n-term expression. So this is the number of terms. So for every number of terms given, I can get a particular word, a particular term. You see that? So once the n-term is known, n-term expression is known, we can use it to find the word, to find the term of interest. So let's flow together on this. The steps, we say take note of the n-term expression. So we want to solve the first question. The n-term expression here is 2n minus 3. Now the first part of the question is find the 5th term. Now this is T5. That's what we are asked to find. For you to find T5, now look at this. This is T sub n. This is a subscript. What number replaced n here? Is it not 5? So it means that in this case now n is equal to what? 5. Because I have T sub n and here I have T sub 5. So if T sub n is this, then they ask us to find T sub 5. That means when n is equal to what? 5. When n is equal to 5, what will be the term when n is equal to 5? So which term will occupy the 5th position? So it means substitute the given value of n in the expression and simplify to find the term. So when we are looking for T5, what is the value of n? The value of n will be 5. So we substitute it there. So we are going to have that T5 now will be equal to 2. We substitute it in the n-term expression. So if we do that, this 2n, n is now 5. 2 times 5 minus 3. And 2 times 5 will give me 10. 10 minus 3 will give me what? 7. So the 5th term is 7. The B part of the equation, we're asked to find the 10th term. 10th term. That's what I'm looking for. And in this case, n is what? 10. Since I'm looking for the 10th term. So the 10th term will become, what value are we going to substitute our n-term expression? Now it's going to be 10 because n now is 10. So that will give me 2 times 10 minus what? 3. So T10 will be 20 minus 3. T10 will be what? 17. It's beautiful. Then let's look at the C, the 21st term. That's what we are looking for. And here n is what? 21. So the 21st term means any place we see n, we substitute 21. So I'm going to have 2 times, still in this expression, n now is 21. So 21 minus 3. So 2 times this will give me 42 minus 3. And 42 minus 3 will give us what? 39. So the 21st term is 39. So you see, we can actually use the n-term expression in finding what? In finding terms, as we can see here. Okay, we need to take another example before we can now give you a take-away question that you will solve. So let's take another example quickly. Example 2. The n-term of a sequence is given by un equals n squared plus 2n plus 1. Find the third and its terms. The n-term of a given sequence is given by this. Find the third and the 8th terms. That's what we are asked to find. So we have been given the n-term expression. So what's the n-term expression here? Un equals what? N squared plus 2n plus 1. That's the n-term expression. Don't mind my ink. That's the n-term expression. Un is equal to this. Okay? Now, so how do we go about this now? How do we go about it? We are asked to find the third term. The third term will be when n is 3, because third term, number of 10, which term we occupy position 3. So the third term, which is U3, we are looking for this, it will be when n is what? 3. Find the third term. Then the 8th term, if we are looking for it, it will be when n is equal to what? 8. So we are looking for the third term and the what? And the 8th term. So we already know the number of 10. Number of 10 in the first case is 3. Third term, position 1, position 2, position 3. So number we counted to get there, that's 3. 8th term will be position 1, 2, 3, 4, 5, 6, 7, 8. So which number will be in that 8th position? So if we do that here, so we'll find U3. We substitute any place we see n now, we substitute 3. So we are going to have 3 raised to power 2 plus 2 times 3 plus 1. 3 raised to power 2 is still 9. 2 times 3 has not changed from being 6. And then plus 1. And 9 plus 6 plus 1 will definitely give us what? 16. So the third term is 16. Then let's get the 8th term now. What will be the 8th term? U8. In that case, in place of n now we are substituting what? 8. So we have 8 raised to power 2 plus 2 times 8 plus 1. 8 raised to power 2 is still 64. 2 times 8 is still 16, and then we have plus 1. So if we add 64 plus 16 is definitely 80. It's not more than 80, it's exactly 80. 16, 64 plus 16 is 80, and plus 1 will give me what? 81. So the sequence that has this n-term expression, the third term of that sequence is what? 16, while the 8th term is what? 81. So if you have the sequence and you have the first term, a particular number there, the second term, a particular number, then the third term is 16. If you continue, the 8th term is going to be 81. So we can still find the first term. In the first term, the number of terms will be 1, so you substitute 1. In the second term, the number of terms will be 2, you substitute 2. Alright, so far so good. So far so good. So what remains now is for us to take a takeaway question. Let's say maybe we'll just be giving 1 or 2 questions. that we are going to enjoy. Yeah. Yes, we need to enjoy equation. So let's have a take away position. So let's say take away positions. Okay. Number one. If the end term of a sequence is Tn equals 3n squared plus 2n plus 1. Find a T7 minus T5 and B 2T3 plus 3T2. Okay? If the end term of a sequence is this is the end term expression, find T7 minus T5 and find 2T3 minus 3T2. So number two, the second question, given that the end term of a sequence is un equals 5n minus 3 over 2, find a u2, u3, and c u7. Okay, these are the questions that you need to solve. Yes, let's check whether you understood what we have done so far on end term of what? Of a sequence. I believe that you enjoyed this part of sequence. Now, till I come your way next time, please make sure you continue to visit our platforms, be it on YouTube, be it on Facebook. We're also on Instagram. We're also on TikTok. Yeah, we are there on TikTok. Yeah, I mean it. We are there on TikTok because we want to bombard every environment with mathematics until every part of your system become mathematical. Don't mind me. All right. Thank you for following us. Please make sure you watch our videos, like our videos, share our videos, leave comment for us, recommend our pages, our Facebook page, and also recommend our channel for your friends and for everyone that is interested in mathematics. If mathematics have shown you Shege and Banza, Mathematics Meal will help you to overcome every Shege and Banza in mathematics. Thank you and God bless you. My name still remains Engineer I, Okechukwu, your tutor and your friend. I love you.